Hello Chemsters, welcome to today's tutorials. Today we'll be talking about calculation of moles in relation to elementary particles. If you have not seen the previous video, please I advise you to do that before you see this video, okay? Now let's go over into the business of today. What is Avogadro's number? Avogadro's number mathematically is expressed as 6.023 exponent 23. Avogadro was an Italian scientist. He worked with carbon C isotope to determine the number of atoms present in carbon. After that, he worked with a large number of elements, molecules, and ions to determine the actual number of atoms in those substances. Based on Avogadro's experiments, these conclusions were drawn. All gram atomic masses of all elements contain the same number of atoms. That is number one. Number two, all gram molecular mass of all molecules contain the same number of molecules. And then number three, all gram formula mass of all ions contain the same number of ions. If it is an element, it means that the number of atoms present in 1 mole of such element is 6.023 exponent 23. If it is a compound, it means that the number of molecules present in 1 mole of such compound is also 6.023 exponent 23. And if it's also an ion, it also means that the number of ions present in such ions is also 6.023 exponent 23 particles. Now, mathematically, this is the relationship. 1 mole of a substance is equal to atomic mass of a substance, which is equal to 6.023 exponent 23. Calcium has an atomic mass of 40. It also means that the number of atoms present in 40 grams of calcium is what? 6.023 exponent 23. Water is a compound. It has an atomic mass of 18. It also means that the number of molecules now, not atoms again, molecules, because we are talking about compound. The number of molecules present in 1 mole of water, which is 18 grams, is equal to 6.023 exponent 23. And also, take for instance sulfate ion, the one I have on the board. The formula mass is 96. So it means that in 1 mole of sulfate ion, the number of particles of ions that are there is 6.023 exponent 23 particles of sulfate ion. Alright, so let's go ahead and solve this so that we understand it better. So let's take the question number 1. The number of what? Particles in what? 5.5 grams of manganese. Now, like I usually say, make sure you write down the given variables. It will help you to deduce the unknown and navigate your way in solving it. Now, 5.5 grams means that the mass of manganese that is given is 5.5. Very good. So we say M. Now, manganese is also in the bracket, which means that the molar mass or the atomic mass of manganese is also given, which is what? 55. So we say molar mass is equal to 55 grams per mole, okay? Now, what is missing? What is missing here is simply the mole. And remember, we are using our mole to equate to the Avogadro's number because the question is calculate the number of particles. So for us to get our number of particles, we must relate our moles to Avogadro's number. Now we can say mole is equal to mass over molar mass. This is 5.5 over 55. When you press your calculator, you get 0.1 mole. This is what we are going to relate to Avogadro's number, which is what? 6.023 exponent 23. Now let's calculate the mole. 1 mole of manganese contains 6.023 exponent 23 particles. This is the standard. We are working with the standard. Now, the one that we have gotten is 0.1 mole. Are you getting it? We have to find the number of particles that is in 0.1 mole. If 1 mole of any substance, be it an element, a compound, or an ion, is equal to this number of particles, what is the number of atoms that is contained in this 0.1 mole of manganese? We do not know. That is the one we are asked to find out. So what do? This 0.1 mole will come under this 1 mole of manganese atom. We contain X particles. I call it X because we do not know the number of particles that it was contained. What are you going to do? You simply cross and do what? Multiply. Now, let's finish solving it. You can now say 1 times X, 0.1 times 6, okay? So for clarity's sake, I'm going to divide my board here and finish up the solving, okay? Now, we say 1 times S. Remember, 1 times S is equals to S, okay? So S is equals to 0.1 times this. We now say 0.1 times 6.023 exponent 23. When you press your calculator, what do you have? You have 0.6023 times 10 to the power 23. Or you can say 6.023 times 10 to the power 22 particles of manganese atom. So that is the answer. Just navigate your ways, like I keep saying. 1 mole has this as a standard. Now, from what you have been given, you have gotten 0.1 mole. 0.1 mole is not equal to 6.023 exponent 23 particles. So how do we get it from this standard? This is just the relationship, and you can simply get your answer. Let's solve for 44 grams of iron 2 sulfide. 44 grams of this iron 2 sulfide. So permit me to write it, the molecular formula, okay? Now, you also have it in brackets. You have the mass, and the molecular mass can be gotten from here. And we'll go ahead and find our mole. We have the mass already, so I will go ahead and write 44. The molar mass, iron is what? 56. Sulfur is 32. When you add, you have what? You have 88 grams per mole. Quickly, let's solve and get our mole. Mole is equals to mass over molar mass. This is equals to 44 over 88. This is 0.5 mole. Are you seeing it? Now, this 0.5 mole is what you will use to calculate the number of atoms. Now, it is no longer atoms. It is the number of what? Molecules. Why? Because it is a compound. So, we say now, for 1 mole of iron 2 sulfide contains 6.023 times 10 to the power 23. I'm just trying to manage my board, okay? Now, what is the mole here? 0.5. I have 0.5 mole. We call it S, okay? You do not know it. It's very simple. You do your simple cross and multiplication. Our S becomes, when you multiply this, what will you get? 3.012 times 10 raised to the power 23 particles of what? Iron 2 sulfide. So that is the answer. Just know that if it's an atom, it is what? For element. If it is for molecules, it is what? Compound, okay? Quickly, let's solve question number 3. 8 grams of atomic oxygen. Now, oxygen is diatomic. It's a molecule because in room temperature it is gaseous. It exists as a gas. It's normally written as this. But now they are asking you to calculate for atomic oxygen. We are going to simply write O because it is what? Atomic. Under normal circumstances, oxygen is supposed to be O2 because it's diatomic. But it is specific here, atomic oxygen, meaning half of it, okay? Now we say mass is equals to 8. The atomic mass is 16. Had it been its molecular oxygen, O2, would have said 16 times 2, which is 32, okay? Now it's just atomic. There is no need to add that to. We simply pick up that 16. Now for mole, we can now say A divided by 16, which is equals to 0.5 mole. That is 0.5 mole. It is the one that you are going to still relate as you have done previously for you to get the number of particles present in atomic mass of oxygen. So we can now say 1 mole of oxygen contains 6.023 times 10 to the power 23 particles, and then 0.5 mole of oxygen atom contains S. Quickly you do your cross and multiply. X is equals 0.5 times 6.023 exponent 23. I think it's the same answer we got here. So we have 3.012 times 10 to the power 23. It's either you call it 10 raised to the power 23 or you call it exponent 23. You can see I toggle between these two. They mean the same thing. Particles of oxygen, atomic oxygen. So that is just the solution. Now this one is for sulfate ion. This is sulfate ion, something like this. Tetra or the sulfaceous ion. You will do well to check the next video where I'll be solving this sulfate ion. This is a radical. Normally we attach it to something like this, right? But this one is a compound where we cannot calculate the number of particles, that is number of the molecules. But why is it only this one? So check the next video where we solve this together. Now it's time for you to do your part. Subscribe, like, do all these things. I'll come and give you an e-hug. Thank you for seeing this video. I'm Ijeoma. Good night.